Okay, we're going to just have a look at some actual real physical stuff versus simulations or on paper. So I have some equipment here. This is a cheaper version of a multimeter. You can get this at a hardware store. And you'll notice it has 4 distinct areas. So voltage for direct current, voltage for alternating current. There's a little squiggly line above the V for alternating current. There's a straight line above the V for direct current. So those two measure voltage. The little horseshoe is for resistance and ohms. And the A is for amperage or amps, and that is for current. Down on the bottom, you'll notice there are 3 holes. The 4 on the other ones over here, but normally if you look down, you can see you're going to put your leads, your connectors, and they look like this. A little plug-in like that. You normally just follow the color. So whatever you want to measure, so in this case, you'd be able to measure voltage, resistance, and milliamps. And you normally just follow the colors, put black and calm. You need to normally, you'll always have to have 2 wires on there, so just leave the calm in, and then you can move the red one back and forth. This is for larger currents, which we're going to avoid for safety reasons. So that's all. You put those in there, and then on the ends, you can have different ends. These are just probes where you can touch them, or you can get alligator clips, a bunch of different things. So let's go through our basics. A multimeter is a voltmeter, an ohm meter, and an ammeter all in one. So the first thing we're going to do is I'm going to put this into an ohm meter. So I'm going to measure resistance. Okay, so there I put it into ohms on the ohm meter. I've got my leads in the right locations. I'll turn it on. We'll get a number going on there. When it comes to an ohm meter or measuring resistance, see if we can get that in a frame. You should be able to touch the 2 leads together. Get over there. And zero it out. Okay, so that's how you zero it out, just to make sure it's working correctly. So I have a tiny little resistor here. Okay, and we can read that color coding on there and get the actual numbers. Or I could put this on to the leads. And let's see. Make sure I'm on the right setting. Well, I'm on 2 million. That might be a little large. I think we need to go down to 2,000. That sounds better. Okay, so that's hard to see. Let me just change that so you can see that number. So I'm on the 2,000 setting. So when I measure that, I get 0.333. So that's a 333 ohm resistor. Okay, and that's all it is. So reminder though, when you're measuring resistance, the circuit is not live. Okay, so you have to make sure the circuit is off when you're measuring resistance. That's really, really important. Okay, so let's go and look at a live circuit. So I have a really basic series circuit here. So I have some batteries down here. They're in series as well. If I take this lead, you can see the lamps will light up. I'm just using some alligator clips. And get on there. There. I have my lights that are turning on. I'm going to take this multimeter I had over here now that I had in as an ohm meter, and I'm going to turn it into a voltmeter. Okay, so I have my 2 leads. Okay, now I'm going to try and set this up so you can see it. Get it on screen here. Is that pretty close? Maybe I'll just lie it flat. It always works like that. There we are. There, I can see the numbers at least. Okay, so now, if I take my leads, something to remember, electricity is colorblind. It doesn't know black versus white, red. It's just going to transfer current through anything. So if I measure the leads here, and I get the voltage over the battery, okay, I just got to work with it, getting a good contact here. Okay, it's being finicky. It's always what happens when you video. Oh, helps to be in the right direct current, not in alternating. See, everybody makes mistakes. 2 is too small. Let's go up to 20. There we are. That's the number we're looking for. So we're looking for about 4 volts. So let's say 3.9 volts. Now in Kirchhoff's laws, we talked about drops and gains. So this is, you could think of this as a gain. So this is what we're starting. Now we have 2 lamps, and if we take our voltage measurement over both lamps and we do these in parallel, you'll see that's 2.1, and you'll notice there's a negative sign on there. All that is polarity. So if I switch the leads around, it changes to a 2.1 again. Okay, if I go to the next one, I'm 1.7. So 1.7 and 2.1, that's 3.9, which isn't a big surprise. That's about what we started with. Okay, there's a few other little resistance things going on here, but for the most part, we should see if this is 4, these will both be 2 each, and that's how we can verify our Kirchhoff law. Okay, so now if we want to do this with current, okay, I'm going to have another one set up here. Maybe I'll move this over so you can see it. So current, to measure current, we need to break the circuit. So we need to have the ammeter in series. Okay, so I have to break this circuit. So I'm going to unplug this. Lights will go out. I'm going to plug it into red, or clip this on to red. And then I'm going to clip this on the battery. Okay, and now we can see we're getting a current. So I'm on 2 amps. So this is 0.234. So this is 234 milliamp, or sorry, 0.234 amps, or 234 milliamps. And there's my series circuit. So you'll notice series, or ammeter in series, voltmeter was parallel, ohm meter was break the circuit, turn it off, measure the parts. Okay, there's some tools for you.